Hey guys, in this video, we're going to discuss Leetcode 253, where we're going to be given an array of intervals, and every interval means the start time and end time of the meetings. And we need to return the minimum number of meeting rooms we need to hold all the meetings in the intervals array. So let's take a look at this example. So we have meetings like starting from time 0 to 30, and another meeting from time 5 to 10, and another meeting from time 15 to 20. So let's go through these meetings. So for the first meeting, we'll go from time 0 to 30. So we're going to need one room for that. And then the second meeting will have an overlap with the first meeting because it's like from 5 to 10. So we're going to need another meeting room to hold these two meetings. So we're going to need two rooms. And for the third meeting, when it starts, the second meeting already finished, and the third meeting overlaps with the first meeting. So we still only need two meetings to hold the these three meetings. So that's why we return two as the number of meeting rooms we need to hold all these meetings. So for this kind of problem, we can use a heap queue to solve that. Basically, what we can do is we can sort the intervals by their starting time, right? In order so that we can, and then we can loop through the meetings one by one. And once we process every meeting, then we can have the heap queue which hold the end time of this meeting, so that when we are processing the new meeting rooms, we can check when this meeting starts if the first meeting has already finished or not. So for example, like this end time is 30, and the second meeting starts at time 5. So the first meeting hasn't finished when the second meeting starts. That's why we need an extra room for that. And when the third meeting starts, the end time for the second meeting is 10, which is smaller than 15, so that we can just pop it out from the heap queue, so that the heap queue size would be 2, which has these two meetings. So with heap queue, when we insert the item, like the minimum value of the end time will be in the top of the heap queue. That's why we can keep popping from the heap queue until the previous meetings end time is larger than the new meetings starting time. So let's take a look at this example and see how it works. So let's say so we're gonna process the first meeting first. So like the meeting start with 0 and at 10:30, right? So we can have a heap queue with that. We only need to store the end time here. So it will have an end time 30 in the heap queue. And then the second meeting starts, right? It will have an end time start at 5. So which 5, when it starts, the end time is 30. So that this one hasn't finished yet. And this end time is 10. So we're going to insert it into the heap queue 10. Since it's a heap queue, so the 10 will be inserted here. And then we have third meeting, 15 and 20. So when 15 and 20 starts, we're going to check the heap queue. So the 10 already finished when the 15 starts. When the meeting starts at 15, this meeting ends at 10, right? So it already finished. So we're going to pop it out, and then we insert 20 into the heap queue. So 20 will be inserted here. Smaller item will be in the top of the heap queue. So that's why we have 20 and 30. So this meeting is completed. So that's why the heap queue, maximum heap queue size is always 2. So that's why we return 2 for this case. So that's code. So basically, we're gonna use the heap queue and then keep popping. In the heap queue, we're gonna store the end time of all the meetings and keep popping up, keep popping from the heap queue when the starting time is larger than the end time. All right, so let's try to code it out. So basically, we need the heap queue. So let's just try to import first. So from heap queue, import heap pop, heap push. Okay. So now we're gonna need first we're gonna need to keep a response, like the number of meeting rooms. So that's a return data. So initialize it to 0, and then we're gonna need a heap queue. So we can just have a queue with empty, and then we need to sort the input intervals. So intervals, and just sort it based on the starting time. T equals MB lambda lambda on the every item on the first line. So we're gonna sort the intervals on the starting time. All right, now we need to process every meeting in order. So for start time and end time in intervals. So start time, end time. So while the queue exists, right? While we have the queue and the start time is larger than or equal to the top of the queue, right? So while we have queue is not empty and the starting time is larger than or equal to the top of the queue, so we're gonna pop out. So the previous meeting has already completed, so we're just gonna pop it out from the queue. So hit pop it from the queue. All right. So this is then we're gonna heap push the end of the end time of the queue. So heap push the queue with the end time. Let's see. So if the start time is larger than that, so the previous meeting already finished, so we heap pop, and then okay. And then now we need to check the size of the queue will be the maximum of the current response and the length of the queue. And then we can just simply return the output. Let's run and see how it goes. Yep, looks good. Yeah, and it runs fine. So basically for time and space, so it's time-wise it's n log n. So we sort it, it's n log n, and then every heap queue or heap push is log n. So and we have n items, so it's n log n as well. And the space is order of n because we have a queue, so it's n. All right, so this is the end of the video, and I'll see you guys in the next one.